Hi, today we are going to learn how to do the graph rational function. So rational function, parent function is y equals 1 over x. This graph all the time, like that and like that. And then that one all the time, this is asymptote, we call it horizontal asymptote, this is a vertical asymptote. So we need to find the asymptote here first. So let's find vertical asymptote. Vertical asymptote all the time, denominator makes 0. Denominator makes 0, that's vertical asymptote. So here, vertical asymptote is x equals -1 is vertical asymptote. Here, in this one, vertical asymptote, x equals 0, right? That's vertical asymptote here. This one, x equals 3, vertical asymptote right there. Okay? And then, horizontal asymptote, we need to find it. Horizontal asymptote is after you find this one 0, after something. So here, in this case, y equals -2. Horizontal asymptote all the time, y equals something. Vertical asymptote, x equals something. Here, same thing, y equals -2. Here, same thing, oh, but that's nothing. So that means 0. Y equals 0 is a horizontal asymptote. In this case, x equals 0, vertical asymptote, and there nothing, so y equals 0 is horizontal asymptote right there, right? So that means let's draw one of those here. So this one, so vertical asymptote number 1, vertical asymptote first. Let's say this is a x plus 1 equals 0. From there, x equals -1. That's vertical asymptote. And then -2 there, that's horizontal asymptote. So horizontal asymptote was y equals -2. So that means you draw the asymptote first. Asymptote here, in this case, -1. X equals -1. This is a vertical asymptote. And then y equals -2. Let's say right here, this is a horizontal asymptote right there. And then graph roughly you can draw like this, like this. Asymptote means just approach, but never touch or cross. Just keep approaching, right? This was vertical and horizontal asymptote. So you can draw the graph like that. So that means that one unit from the original 0,0. So parent function, 1 unit to the left, 2 unit to the 2 unit down. So from here, 1 unit x, -1 means 1 unit left. Y -2 means 2 down. So 1 left, 2 down. So that's graph from original function is like that. Now we find out, we draw the more complicated rational function. So there's a 3 different type of rational function. So one is, we call it the numerator degree is 2, the denominator degree 1. So numerator degree is bigger, we call it top heavy. Okay, top. And this bottom denominator is bigger, we call it bottom heavy. And same, this is second degree, that's the same. Those are 3 different types. So, but still, vertical asymptote is the same. Vertical asymptote, do you remember? The vertical asymptote all the time, denominator makes 0. So here, x minus 1 equals 0. So x equals 1 is a vertical asymptote right here. This one, this denominator is 0, but you need to factor it. X common factor out, then x times x plus 2. Then make it 0, then 2 vertical asymptote in this case. Vertical asymptote now, this equals 0, so x equals 0, so, and this equals 0, x equals -2. 2 vertical asymptote here. And this one, also same, x plus 2, x minus 2, you can factor out like that. That equals 0, so vertical asymptote again, 2 of them, x equals -2, x equals 2. There's 2 vertical asymptote there. Now, horizontal asymptote that matter. Horizontal asymptote is you divide numerator with by the denominator. This division, you do division, and quotient is horizontal asymptote. So let's do each one first. So this divided, then same degree. Then you don't need to worry about the following. Just 2x squares over 2x squares over x squares. That become cancels out. So y equals 2. This is y equals 2. And this denominator is bigger, so bottom is heavy. That means this is like that, 5 or 12. Denominator is bigger, then quotient is 0, right? So same, that bottom heavy, denominator is a bigger degree, then this is horizontal asymptote equals y equals 0. Only matter top heavy. Then this one you need to do the synthetic division or long division. Let's do synthetic division. So 1, leading coefficient 1, and 2, and negative 15. And then, so all the time you write it here, making denominator 0. So denominator is x minus 1, so that make it 0 is 1. So you can write it this 1 there. Synthetic division, now you down first, this is 1, and you multiply, that's 1. You down, 3. And you multiply 1 times 3, 3 here, negative 12. This is called remainder we don't need it, only this constants and then plus, and then this means first degree, so x plus 3, so horizontal asymptote is y equals x plus 3. This one we call it actually slant asymptote. I'm going to explain soon why. Okay. So let's draw each graph. Let's draw this one first. This origin vertical asymptote equals x equals 1. So let's draw that first. So x equals 1. Let's say right here, this graph. This is a 1. And then y equals x plus 3. So 1, 2, 3, y-intercept. Right? Slope is 1. So slope is 1. Then you graph 1 over 1. That's 1 up, 1 to the right. So 1 up, 1 to the right, like that. So you connect them, graph like that. So two lines, this line and this line. But this line not like an exact horizontal asymptote. So we call it, the correct name is slant asymptote. But anyway, these two lines divide by this plane at 4 different sections. This top right here, 1 and 2 and 3 and 4. Among those, this cover which which sections. So all the time, this vertical asymptote to the right side and the left side you need to choose. So this is 1. So I want to find out where. So I find just 1 point from each section. So here, let's say plug in 2. Let's find 2. Then from x value, let's find y value. So I'm going to plug in this 2 to the original function. So 2 squared plus 2 times 2 minus 15, and x was 2 minus 1. So this is a 4. This is a 4. So 8 minus 15 over 1. So this is negative 7. So 2 comma negative 7, let's say right there. So 2 comma negative 7, this graph function should pass through. So that means because this is asymptote, because you're not passing through this point, then instead of this section, this cover this section. So you draw the graph like that. That's approaching this line, but never touch or cross. And then vertical asymptote, never touch, but just approaching just like that. If when we plug in 2, let's say maybe 10 up there, then graph is gonna be something like that. But this one is right here, right? Okay. And then let's plug in here when x goes 0. When x goes 0, let's plug in right here. So 0, 0, 0. Then this is negative 15 over negative 1, which is 15. So 0 and 15. Let's say this is 15. So that means graph something like that, because this is asymptote, this is asymptote, just approaching like that. So graph of this line, this function is the blue one with the red asymptotes. Okay, let's do one more here. Let's find out asymptote first. Number 1, vertical asymptote. Do you remember? I factored it, this one. So from there, x goes to x equals -2, which make this denominator 0. I found that way. And the horizontal asymptote, I found the quotient of this division. But when this same denominator, degree, then you don't need to rub the following, just 2x squared over x squared. So y equal to, that's the horizontal asymptote. So let's draw the graph with that asymptote. Okay, so x equals to 1, 2, let's say right here. That's one vertical asymptote. 1, 2, that's -2. So that's one of the vertical asymptote. That's a 2, that's a -2. Okay, this particular asymptote divided by this plane as 1, 2, 3 sections. But now y equals 2. Y equals 2 is 1 and 2. This line now with this 3 line, 1, 2, 3, 4, 5, 6 section. So it's divided by this plane as 6 sections. So now you know to tell which among 1 and 2 which section they pass through. So let's plug in 3 there. So original equation you can plug in 3. So let's plug in 3 here. So that means what? 2 times 3 squared minus 2 over 3 squared minus 4. So this is 9 times 2, 18 minus 2, that's a 16. And 9 times 4, that's 5. So that's what? About 3 point something. Yes, that's a 2. That's a 2. So 3 point something will be somewhere here, right? So then this is a asymptote, this is asymptote, then this graph on that side, that section, gonna be something like that. Okay, let's draw with a blue line, blue one, like that. Okay, and then let's find out here. Then you might plug in 0 there. So let's plug in 0. Then 0, 0. So then everything cancels out. That becomes -2 over -4, which is 1/2. That means 1/2 right there. So this is asymptote. This is asymptote. Graph something like that. Okay, let's plug in. And then 5 and 6 among those sections. So which one pass through? Let's find out. So let's plug in -3 here. So you plug in -3 here. Oh, because square doesn't change anything. So that's a 16 over 5 again. When you plug in -3, because that's a square, the same thing, same value, right? So same again. So 3 point something right here, right? So that's the graph of this one. Okay. So, but one more thing you need to consider for the rational function when there's a hole there. So let's, for example, let's do this. Okay, we did that. Number one, vertical asymptote denominator 0, right? But before you do that denominator 0, what do you need to think? You need to factor in numerator and denominator. So this is x squared plus x minus 6. You can factor it xx. Factor of 6, -6, and 1 and 6, and 2 and 3, right? But this -1 should be negative. Then it's different. Difference 5, difference 1. But this is difference should be 1 there. So we pick this one. So 2 and 3, right? So in order to be plus 1, this is plus 3, this is -2. So product is -6, sum is 1. So this factor, x minus 2 times x plus 3. You can factor that way. And here, denominator, the x minus 2 was there, right? So when you look at that, denominator is x minus 2, but numerator is x minus 2. Oh, this is exact same, I can cancel this out. So this is there's no bottom, then no vertical asymptote anymore. But this, both numerator and the denominator make 0, 1, we call it, instead of vertical asymptote, we call it hole there. So you will unexplain soon with the graph. So that means now that this equation becomes y equals x plus 3. This is exactly line. Y equals 3 is a line. So line you draw, y-intercept first, 3. So 1, 2, 3, right here. And then slope is 1. So slope is 1 with a slope. That means 1 over 1, right? Nothing means over 1 there. So y, move 1, which is 1 up. And x, right unit to the right 1 unit, so 1 comma 1. So graph is something like that. So this x plus 3 line is just like that, right? But this is a little different, almost same, but because this has hole, then that hole is, you can find hole where? So x equals 2, so x put 2, after you cancel out, you put 2 there, so 2 plus 3, that become 5. So 2 comma 5, that will be hole there. So 2 and there will be 5. So this is just x plus 3 is just line, but this function same as that line, but it has a hole in the middle right there. So you need to check all the time rational function where is the hole or not. Or you can draw with a vertical asymptote first, horizontal asymptote, or slant asymptote. And then each section 1 and 2, which one you need to choose, you solve, draw the rational function that way.